6.2, graphing polynomial functions. You'll graph polynomial functions and identify the zeros, which we're doing in section 1, maximum and minimum values, which we did last unit, and then the end behavior of the polynomial, which we did last section. So we've already done everything. We're now putting it together to be able to graph. Okay, so if p of x, using p as a polynomial, function of degree n, the graph of the function has at most n real zeros and thus at most n x-intercepts. At most n minus 1 turning points, also known as the max or min. So let's use an example of x squared. Y equals x squared. So at most it has 2 real zeros, and at most it has 2 x-intercepts. And at most it has n minus 1, so 2 minus 1 turning points, or max or min. And just x squared alone has a minimum value. Now, this one is only going to have 1 real zero, and it's only going to have 1 x-intercept. You cannot have 1 real zero and 2 x-intercepts. That's not the way it works. And then on this one here, it's going to have the 1 turning point, guaranteed the 1 turning point. Okay, now if I gave you y equals x cubed, you can have as many as 2 turning points, but not necessarily will that happen. You can have 1 turning point. So this is just a matter of playing with graphs. You're not going to know by just looking at the polynomial function on how many it has. Okay, so first example for the function, the maximum number of real zeros that the function can have, the maximum number of x-intercepts the function can have, and the maximum number of turning points. So this is a degree 4. Let's identify it. Degree 4, which means for part A, the maximum number of real zeros it can have, 4. Part B, the number of x-intercepts, which is the same as real zeros, is 4. And C is going to be 4 minus 1, so 3. So we can have as many as 4 real zeros, 4 x-intercepts, and 3 turning points. There's only one example there. Okay, and then they get into graphing. So now all of these steps are just here to help you out. Use a leading term test to determine if the end behavior, if it's going up, down, one's down, whatever's going on. Find the zeros of the corners by solving f of x equals 0, so that's the last section. Any real zeros use these first coordinates of the x. So you're going to plug those in to figure out where the graph is at. Use that the graph has at most n x-intercepts and n minus 1 turning points. Multiplicity of zeros can also be considered in order to check where the graph crosses or is tangent to the x-axis. This is actually quite important. So anyways, you're going to plug in these x values, and at this point you can identify if it's going to cross or if it's going to be tangent and touch. You can also at this point identify using your end behavior what's happening. Anyways, is it coming down and crossing, or is it coming up and crossing? Okay, and then in step 4, use the x-intercept or zeros to divide your x-axis into intervals and choose a test point or points in each interval to help determine the max or min. You may not actually find the max or min, but you're going to get a good idea of where it is. Find f as 0. This gives the y-intercept. This can be done at any point in time. You can do that the very first step if you wanted to. So this one can be done at any time. The other ones pretty much follow a nice flow. Okay, so let's look at the first one. So step 1, they ask you to use a leading term to determine what's going to happen. Okay, it's x to the 4th, so it's an even number, which means both sides are up or down. It's positive, so both sides are going to be up. This is a big help because you know if when you graph this thing, you got one going down and one going up, that you made a mistake somewhere. So there's the first step that they tell you to do. Step 2 is find your zeros. All right, so step 2, have to do some factoring. So x squared, common factor throughout, leaves me with x squared minus 4x plus 3. And if I factor this guy, I get factors of 3 that add up to -4. And there's only one set of factors of 3, that's 3 and 1. But because this guy's negative, they both have to be negative. And if I use the wagon wheel idea, divide by the leading term with leading coefficient, which is -1. You do the -1 to change the sign. And so here I get 3. And here I get 1. And here I get 0. If you factor out as next, don't forget that that one's going to give you 0. So this is 3, 0 with a multiplicity of 1. This is 1, 0 with a multiplicity of 1. And this is 0, 0 with a multiplicity of 2. Squared. Happens twice. So I have, and the next one says to use a graph. Okay. Not really sure that 3 is going to use that the graph has at most this one multiplicity. So we're actually doing step 2 and 3 together. So step 4 tells you to break up the x-axes. So this is 0. Try and get in there so nice and big so you can see it. And then I have a point at 1. And then I have a point at 3. Now here's one of the things to remind you of. 0 has a multiplicity of 2, and it's my first intercept. Now I can go through with the idea that this is 4, so I can have as many as 4 real zeros. I have 3. So in this case we have 3. I can have as many as 3 turning points, but it has to be 1 less the number of zeros. So I really am going to have 2 turning points. Now that one we may have to discuss more in class. It's just that you can't have 3 zeros and 3 turning points. Your turning points will always be 1 less than your zeros. Now we know it starts up, so this guy is going to do this bit. And since this guy is up, this guy will cross this way, and then this guy will cross and bring it back up. So step 4 says to use these points to find points in between. So I'm going to do f of 1/2. I'm going to do f of 2. I'm going to do f of 4. I'm also going to throw in there that I'm going to do f of -1. What that does is that gives me at least a point before I hit any of my zeros. So if I put in -1, I'm going to get 1 plus 4. Anything to even power is positive. -1 times -4 is going to give me +4. And that was going to stay positive as well, plus 3, which gives me 8. So -1, 8. Now here is something else to share with you, is that be really, really cautious with your scale, with your graphs. X, -x, Y, -y. Unless you tell me otherwise, I will assume you are going by ones on your scale. Each square is representing 1. If you do not say anything and your graph is off, it's because you didn't say, you left something out. So be really cautious on that. Okay, -1/2 is 0.3125 or 5/16. That lets me know it's just under a half. So it's going to be right about here. So you're going to see that this thing, oh, that's positive 5/16. Let's wake up. Okay, try that one again. It's going to be right about here. And f of 2 is -4. So 2, 1, 2, 3, 4. And then f of 4 is 48, so that thing goes flying up here. I can't graph it. But I can at this point go, here's what this graph is going to look like. Okay, it's going to be kind of squirrely, but it's going to come up and go back down very, very quickly, go down here, and then come back up, and it's going to look almost, actually it's going to be almost a straight line up. If you were to put this in a calculator, it would look like it's going almost straight up. But that's what you guys have on this one here. When you draw this graph on your own, you'll probably get something much nicer looking than what I could possibly draw here. Okay, now the video looks like it might go just a little bit long, but that's going to be because of, I'm not going to stop the video. It's all graphing. Every one of these are. Okay, the next one, x cubed minus x. So the very first thing they ask you to do is that in behavior. It's an odd power and positive, so the left side is down and the right side is up. So that's what we got going on there. Step 2 is find your zeros. I have a common factor of x. So I have x times x squared minus 1. So x equals 0, or x squared minus 1 equals 0. And x squared equals positive 1, square root both sides. Then you get x equals positive negative 1. So on this one, we're going to get 0, 0, negative 1, 0, and positive 1, 0. Now, just like the last problem, the y-intercept came in with the x-intercepts. That's why I didn't do step 5 on the last one. And this is also why I stated that you can do the y-intercept at any point. It doesn't matter. But you can see here, I have no constant. It's plus 0. I can only slow down there. Plus 0. And that gives you that 0, 0 value. Now, because these values are so close together, I am going to scale my graph by 2s, or by, each square be a half. And I am doing that only because these values are so close together. And I'm going to do the same thing this way. This is going to be positive 1, and this is going to be negative 1. And this is what I mean by you have to identify it. Some people will write up there that each square represents a half, and that's okay. I can find it and see what you're doing. Okay, let me plot these points. I have a point here at 0, 0, a point at negative 1, 0, and a point at positive 1, 0. So when I look for the other points, I'm going to look for f of negative 2, f at negative 1/2, point between 0 and negative 1, f of positive 1/2, the points between 0 and 1, and then f of positive 2. I want to see what's going on both sides. By the way, I know that my graph will be up here somewhere, and it's going to be down here somewhere. That is just a quick double check that I did not make a mistake somewhere along the line. Okay, so if I put in negative 2 into the calculator, I'm going to get negative 6. If I put negative half into the calculator, I get 3/8. If I put positive 1/2 in, I get negative 3/8. And if I put in 2 into the calculator, I get positive 6. By the way, if you haven't caught on, this is an odd function. Negative 2, negative 6, positive 2, positive 6. Okay, so negative 2, negative 6. Oh, I'm going by ones. I have to remember this, that we're not going by ones. There's 1, 1, 2, 3, 4, 5. Kind of went off the graph here. This is a 0. At 1/2, it's not quite a half. And here, and at positive 1/2, again, not quite 1/2. And then here, and then guess what's going to happen on the other side? It's going to go off the graph, just like the other side did. All right, so I'm not going to worry about the fact that I've got to grab these graphs down there. What I'm looking for is what's going on here. That comes up barely, 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 and then keeps going that way. and there's your graph. A lot of times it's not what are the values, it's what is happening in between those n values. Anyways, anytime we were talking about a polynomial, we're usually going to be most concerned of what's going on right here. What are my zeros? What is my max? What is my min? Okay, let's try the next one. Okay, this one here I have marked to do in class, and it's more because of the values that we get than anything else. So I'm going to go ahead and start it. We're just going to talk about the graph and everything in class. So I'll make a note to finish in class, but we're going to go ahead and start it in the video. Okay, one of the things I want to point out is this is already factored. This is a power of 3 and this one's a power of 1. And when we multiply two terms together, you get the two bases, you add the exponent. So this is a degree of 4. So your in behavior, positive on the outside, positive on the outside. So this is what your graph is going to do. A lot of students will get this one confused and just say it's 3, but it's not 3. This has a power of 3 on it. This one has a power of 1. If I expand this guy out and multiply it by this, I will get a power of 4. Okay, our zeros, because it's factors, is going to make our life easy. X minus 2 equals 0, so we get x equals 2. So that's 2, 0 with multiplicity of 3. And then x plus 3 equals 0. So x equals negative 3. So we get negative 3, 0 with a multiplicity of 1. 2 zeros means it has 1 turning point. Okay, so at this point here, the only other thing left to do is find all of our values. I mean, I can plot these points, 2, 0. Here's 2, 0. And 1, 2, 3, negative 3, 0. They're both going to cross through because they're odd on the multiplicity. But here's what we're going to do. We need the values of f of 4. Wait, negative 4. I'm looking at this guy. F of negative 4, we already know negative 3. F of negative 2. F at negative 1. F at 0, our y-intercept. F at 1. We already know at 2 it's 0, and then f of 3. What we want is if these values, especially these endpoint values, are nice values to graph, we want to go ahead and graph them, but that gives us an idea of how fast it's moving up or down. So this is where we'll finish off tomorrow or whenever we get the chance, because this graph goes off the grid, and that's why I want to talk about it. Okay, last one that we're going to graph, negative x cubed plus 2x squared minus 4x minus 8. So in behavior, power of 3, and it is negative. So instead of going up left to right, it's going to come down from left to right. The graph is going to have this approach on it. So that's going to be the in behavior. We need to factor this one out. Again, you can use the box or the grouping method. I'm just going to do a quick grouping method this way. Common factor between these two. I'm going to go ahead and pull that negative out of this guy. So I'm going to pull out a negative x squared, which will leave here x minus 2. And remember, the second parentheses has to have the same factors of x minus 2. And if I pull a factor out of here, it's going to be 4. Since I have nothing in front of the x now, it's going to be 4. So plus 4. So my factors are x minus 2 and negative x squared plus 4. So x minus 2 equals 0, x equals 2. So I get a point of 2, 0. This one, negative x squared plus 4 equals 0. Negative x squared equals negative 4. Divide by negative 1, x squared equals 4. Square root both sides. And we get x equals plus or minus 2. So we get 2, 0 and negative 2, 0. But we already have 2, 0 once. So that gives me, we'll talk multiplicity, this gives me a multiplicity of 2 and 1, which makes this one tangent and this one will cross. So graph the points over here, 1, 2, there's my negative 2, 0, positive 2, 0. And remember the shape of the graph, which means it's going to come down here, come up, and this is the one that's tangent, so it's going to come up and go back down. Now the points in between, I need f of negative 3, f of negative 1, f of 0, f of 1, and then on the other side of my 0, f of 3. This will also verify our end behavior up here. So at negative 3, my value is 25, so we obviously won't be graphing it. Negative 1 is going to give me negative 9. 0 is going to give me negative 8. Positive 1 is going to give me negative 3. And positive 3 is going to give us negative 5. So like I said, I'm not going to graph this one because it's way off the scale, but negative 1, that should not have given me negative 9. Should not have given me negative 9, should have given me positive 9. No, it crossed first, that's right. Negative 9 down here, and then negative 8, unless I off my graph. Nope, that's it. Negative 8, and then negative 3. This guy here is at negative 3, and then 0, and then back down to negative 5. 1, 2, 3, 4, 5. So my graph is going to come down very, very quickly down, and we can see that. Because of, okay, I'm not doing a very good job at graphing this. Let's try this one more time. I really try to get this to be nice and smooth when I draw these down. And then it's going to come back up, not along the x, not along the y-axis. It's going to come up. Wow, it's like it's just drawing right over it. Okay, try this again. It's going to come up, and it's going to continue coming up. It'll hit that 0, bounce back down, and continue coming down. And then this side is going up. And there we have it. When you guys draw it, it's going to be looking a lot nicer than mine is looking, because mine is not looking pretty at all. All right, wow, 23-minute video, unfortunately, but it's all on graphing, because the second half it only has 2 examples, and that is it. I'm not going to put that in a separate video. So I can apologize for such a long video right now. Okay, intermediate value theorem. For any polynomial function p of x with real coefficients, suppose that for a does not equal b, p of a and p of b are of opposite signs, then the function has a real 0 between a and b. That's all it tells us. If the signs don't change, they say they're opposite signs are the same, tells us nothing. Okay, so let's look at these as examples. It says use the intermediate value theorem to determine if possible whether the function f has a real 0 between a and b. Well, all we have to do is use a calculator, f of 1, and f of 1 is going to give me 1 plus 3 minus 9 minus 13, which we can tell is going to be a negative number of negative 18. and then we do f of 2. We'll get 2 cubed plus 3 times 2 squared minus 18 minus 13, which is going to give us another negative number of negative 11. Now, determine whether or not there is a real zero. We cannot determine this. There's two reasons. Either there is no zero, 1. 2, there's more than 1 between the two. There's more than 1 0 between the two. Now it can happen, but it doesn't happen that often. And I know I said 2, but 3 follows this one. A multiplicity of an even number. Okay, so I can explain number 3. F of x, okay, f of x equals x squared. Multiplicity of 2. My 0 is at 0, 0, and it's a multiplicity of 2. The graph goes down, hits 0, and comes back up. And what I'm trying to point out is if I did f of negative 1, I get 1. If I do f of 1, I get 1. But we know there's a 0 in between. And that's why we cannot determine if there's a 0 between these two or not, because of this. There's other possibilities that are going on. There may not be a 0 there. There may be more than 1 0, or you might have the multiplicity effect going on. So you cannot say, oh, no 0 here. No, all it tells you is that there may not be a 0 there. Okay. Now, let's try another one. This one here, they're giving you the same values again. They want f of 1. So it gives us 2 minus 7 plus 1, which is negative 4, unless I did my math wrong. And then f of 2, which is going to be 2 times 2 to the 5th power minus 14 plus 1, which is going to give us an even number, or even a positive value of 51. Since it went from negative to positive, there is a 0 in the interval of 1 to 2. Now, we can't claim if there are many zeros. We just can claim there is a 0. All right, that was the last one. Like I said, that took me 4 minutes to go through. I was not going to do another video for 4 minutes. So this one here, there's the homework for these ones, 1 through 11 odd, and then 13 through 39 every other odd. All right, do start on the homework, especially like the 1 through 11. You probably find that those are fairly easy to do. Even the other ones are going to be fairly easy. The graphing ones are probably going to be the ones that will take you the most time. All right, and we do have graph paper in the classroom, and I would prefer that you use it. All right, good luck.